Hey there, Keys Precalculus. I decided to go ahead and make a video for section 9.1, example 4, because we did not get to finish it in class. Before we get started on that problem, though, I wanted to remind you of the reflective property of a parabola that we looked at. That's the top of page 636. It says the tangent line to a parabola at a point P makes equal angles with the following two lines. Now, I have a parabola here, the red one, and I have the tangent, which is a blue line, and it's tangent at that particular point, which we're going to be using this in example 4 in a minute. But here is what the reflective property of a parabola says. It says you have equal angles with the line passing through the point P, in this case it's the point 1, and the focus of the parabola, and the axis of the parabola. So I marked those little angles up here. I don't know if you can see them, see my cursor, but there's an angle here. That angle is congruent to that angle. What that gives us, as we discussed in class, is an isosceles triangle. That means that this line here, this segment between the focus and this point, is congruent to this segment, which is between the focus and the y-intercept, or where the line intercepts the y-axis. So that's just a reminder of the reflective property of parabolas, which we are going to use when we do example 4. Example 4 on page 636 of your book says find the equation of the tangent line to the parabola given by y equals x squared at the point 1, 1. So I've got a graph here of the parabola y equals x squared, that's red, and it says find the equation of the line tangent to that parabola at the point 1, 1. So in order to do this, the easiest way to find the equation of a line is to use, in this, well, not always, but in this case the easiest would be to use the slope-intercept form, y equals mx plus b. But we need to figure out what b is, and we need to figure out what the slope is. So we are going to use the reflective property of parabolas to figure those things out. We're going to use the distance formula, we're going to use the slope formula, and we need to use this equation y equals x squared to find out what our focus is, what the coordinate pair for the focus is. Now, if you will recall, we learned that the standard form of the equation of a parabola with a vertex of 0, 0, which in this case it has, is either x squared equals 4py or y squared equals 4px. Well, we've got the x squared equals 4py, so basically 4py equals x squared here. But in this case, what is the 4p? Well, it's 1, right? It's the coefficient of y. So because I know that, I can figure out what p is. And remember, p is the directed distance between the focus and the vertex of a parabola. In other words, it's how far the focus is from the vertex, and it also gives direction, which direction it's in. Since my coefficient is 1, my coefficient of y is 1, I know that 4p has to equal 1, and I can use that to solve for p, so I get p equals 1/4. So now I can use that to find the ordered pair, or the coordinates of my point P, or my not my point P, excuse me. I can find the coordinates of my focus, which is this red dot right here on the graph. If I know that the vertex of this parabola is at the point 0, 0, then I can find the focus by adding 1/4 to the y coordinate. And I add it to the y coordinate because it is on the axis, the vertical axis, and the vertical axis is parallel with the y-axis. Therefore, I'm going to go take this 0 and I'm going to add 1/4 to it, and so my focus is going to be the point, same x, but 0 plus 1/4 is 1/4, because it's going up because it's a positive. And I know all this. I know it's a vertical axis because my x is squared, and I see my vertex is 0, 0. Now, in the problem you're given in the book, they don't have the graph drawn, or they do have it, but the thing is you're not going to be having a graph drawn for you. You're going to have to draw it yourself. But you know what the graph of y equals x squared is, just the basic parabola looks like. And you can find most of your parabolas fairly quickly. Or you can generalize it knowing which direction it opens and where your focus is compared to where your vertex is. But anyway, I digress. Let's get back to this problem. What I need to do is find the y-intercept of this blue line. I know it goes through the point 1, 1, and I'm going to have to find the slope in a minute, but if I find the y-intercept, then I can use that to find the slope. Now, if you'll recall, I had those two little yellow lines on the graph earlier. I'm going to put them back, so hang on just a second, and I'll come back with them. I don't know if you can see them very well. You may have to zoom in, but I drew little yellow lines from the focus to the point on the line that's tangent to the parabola, and from the focus down to the point where the line crosses the y-axis. We know that those two distances are equidistant from each other. So if we set them equal to each other, we can find the b coordinate. Now obviously I drew it up here so you can see it just by what I drew, but you won't have that access to that normally. So I just drew it so you could see it as we work through the problem, but you can figure it out algebraically without actually having an accurate drawing. So the way you do that is you know that B is a certain distance from the focus point. This is the point B, this little blue dot here. In fact, let's see, I can put the little letter B here. So I can find that distance, and when you can find a distance that's on either a horizontal or a vertical line, you just have to subtract their, in this case, because it's a vertical line, the y values. If it was on a horizontal line, you would subtract the x values, but here, I'm just going to subtract the y values because the x values are the same. So all I need to know is how far it is from the focus to point B. So my equation for that would look like my first distance, distance 1, is equal to the y value of the focus minus the y value of the b, because we know the x value of the b is 0. Don't know what that is yet, but that's going to be my first equation. My second equation, d2, is going to be the distance between this focus and the point 1, 1. Now, I know that the coordinates of the focus are 0, 1/4. Did you see how that magically appeared? And I know that the point that I'm trying to get to is the point 1, 1. And if I know the coordinates of 2 points, I can find their distance using the distance formula, which I put up here in green. So now all I have to do is plug in the numbers. Okay, so my x1, I will let my x1 be the point 1, 1, or excuse me, my first point will be the green point 1, 1. My second point will be the focus, point 0, 1/4. So my x1 is going to be 1, and I'm going to subtract 0 from that and square it, plus my y, I don't mean 1, I mean 2. It really doesn't matter as long as you go in the same order. My y2 or y1, whatever it is going to be the point 1 also, and I'm going to subtract 1/4 from that and square it. So I say simplify down. This is going to become 1 squared, which is 1. So I really don't need the square. I'll go ahead and erase it. And then plus 1 minus 1/4 is 3/4. And 3/4 squared is 9/16. And when I add 1 to 9/16, it's 16 over 16 plus 9/16, which gives me 25/16. But I'm taking the square root of it, so when I do that, I'm going to take the positive because I'm doing a distance. It's going to be 5/4. So my D2 is 5/4. So I know that my first distance, this D1 right here, that I just write D1, is equivalent to D2. And so, because I don't know all of the parts of my D1, I'm going to just rewrite the whole equation. So 1/4 minus b equals d2, which I solved for 5/4. Okay, as I said, d1 is equivalent to d2. The distance of the one little yellow line or segment is congruent to the distance of the other little yellow segment. So anyway, I'm going to solve for b here. So I'm going to add b to both sides, subtract 5/4, and then use a commutative property. So I've got b equals 1/4 minus 5/4 is negative 4/4, which is equal to negative 1. So b is negative 1. My y-intercept is negative 1, so the coordinate pair, or the order pair for this, is the point 0, negative 1. And now that I have 2 points, they can find the slope between them, which I added here in green. So this is my slope formula. Remember, it's the difference in y's divided by the difference in x's. So, and it doesn't matter which is my y2, which is my y1, as long as I go in the same order. So I'll use my difference in y's first. So I'm going to say 1 minus the negative 1, which is the same thing as saying 1 plus 1, over 1 minus 0. So basically I have 2 over 1, so my slope is 2. So now that I have my slope and my y-intercept, I can write the equation of the line. Y equals mx plus b. So y equals the m is 2. X plus b is negative 1, so it's minus 1. So here is the equation of the line tangent to the parabola y equals x squared at the point 1, 1. That's how you solve it. I hope this helps you with the problem that you have to do like this on the homework. The problem follows it, the application problem. I'm going to let you work on that yourself. You're going to have to draw a graph, and you're going to have to write an equation, but you're going to be using the parabolic equations, and then you're just going to plug in points. Okay? So y'all have fun with this, and I will see you Thursday.